Hey guys, welcome back to another video. My name is Melina, and today we're going to be talking about how to make imines, enamines, and the Wittig reaction. With imine formation, it is a condensation reaction. In this case, it means that at some point throughout the mechanism, you're going to result in water, and we're having a primary amine react with a carbonyl, and this is happening under slightly acidic conditions. Something I want you guys to notice about the starting material and the product is basically what's changing is that the oxygen on the carbonyl is getting switched out with the amine. So you have the primary amine right here. So let's look at the mechanism. So the first thing that happens is the lone pairs on the nitrogen in the primary amine are going to nucleophilic attack the carbonyl carbon, and these electrons get pushed up to the oxygen. So now in this structure, you have the primary amine attached, but now it's attached and by 2 by 2 R group, so it's not primary anymore. So the nitrogen is attached, and you have a negative charge on the oxygen. So what that wants to do is that it wants to get protonated. And remember that we're doing this under slightly acidic conditions. So with the slightly acidic conditions, the primary amine, some of it becomes protonated. So, excuse me. This is the primary amine it has another hydrogen, so it has a positive charge. So the negative charge on the oxygen is going to deprotonate that, so it can become neutral right here. And then what we're going to have is, I should move this, I moved it. Okay, so now what we're going to have is another primary amine is going to come and use its lone pairs and deprotonate this hydrogen and push the electrons onto here to get rid of this positive charge that's on the nitrogen. So now you have a neutral nitrogen right here. So now that you have the primary amine that's protonated, you're essentially going to use that and protonate the hydroxyl group so that it becomes water. And remember, I said that this is a condensation reaction, so this is the water that's going to leave. So now that the water is capable of leaving, it's going to leave, and there's another lone pair on this nitrogen that's not depicted, but this lone pair is going to be pushed on to form a pi bond to form this structure right here. But so we're almost done, right? Now what we want to do is get rid of this extra this extra hydrogen that's on the nitrogen to get rid of the positive charge. And what happens is that the primary amine, again, it acts as a base and it deprotonates this hydrogen, and you get your neutral amine. Good. Okay, so next, if we go through enamine formation, it is basically the same thing. The only thing that's changing is that you are reacting with a secondary amine. And this is also under slightly acidic conditions. So let's go through this again. Okay, so the secondary amine has lone pairs on the nitrogen, and these are going to nucleophilic attack, and these get pushed up. So now you form this structure right here. Same thing that happened in the imine formation. And now, remember, this is under slightly acidic conditions, so your secondary amine will get protonated under these conditions, and you can use that as an acid. So the negative charge on the oxygen wants to be neutralized, so the lone pairs on this oxygen are going to deprotonate one of the hydrogens and become neutral right here. It's going to form the OH. Now you still have a positive charge on this nitrogen, and you want to get rid of that. So you're going to use your secondary amine. It's going to act as a base and deprotonate this extra hydrogen. Now you have a hydrogen that has no charge. So now you're going to use this protonated version and take off another hydrogen, so this can become water. Remember, it's a condensation reaction, so you're going to result in water leaving at some point. So the water leaves, the lone pair that's on this nitrogen is going to form a pi bond, and you result in this structure right here. So if we were doing the imine formation, we would be done. But in the enamine formation, you still have a positive charge on this nitrogen, and you don't want that to be there. So what we're going to do is we're going to deprotonate this hydrogen and form a pi bond right here and move these electrons to form a lone pair, so that the charge on the nitrogen goes away. So you form this structure right here. And this is the enamine. Next, we're going to go over the Wittig reaction. This reaction is kind of weird. It's something you guys don't really work with cyclic structures in mechanisms, so we'll go through this. Basically, what's happening is an alkyl halide is going to go through these steps in the mechanism, and you form an alkene of some type, and this oxygen double bonds to a phosphorus with 3 phenols. And this is something that will always result in the Wittig reaction, and then you'll get variations of different alkenes depending on what you're reacting. So the first thing that happens is there is a lone pair on this phosphorus, and it's going to attack this right here, and the bromine leaves. So now you have phosphorus with a positive charge attached to this carbon, and then has 2 other carbons. And then the second step is that you're going to have this hydride. Remember that this is hydrogen with a minus charge. It has lone pairs, and this allows it to deprotonate the hydrogen that's attached to this carbon, and that these electrons get pushed to become a lone pair. Like this. Now you have a positive charge on the phosphorus and a minus charge on this central carbon. And this structure right here is called an ylide, and the ylide is going to react with a carbonyl. So what happens is I like to draw this step where the oxygen is near the phosphorus, and then the minus charge is parallel to the carbonyl carbon, just so it makes the arrow pushing a lot easier, because you're going to form a ring structure. So what happens is the electrons that are right here are going to attack the carbonyl carbon, and one of this pi bond is going to form a bond with the phosphorus, and you form this structure right here. So you form this square structure, and then what's going to happen is this bond is going to form a bond between the phosphorus and the oxygen, and then this bond is going to form the double bond, and you result in this structure and this structure. This is the alkene you're forming. So this so let's label this carbon 1. It has 1, 2. And this carbon 1, 1, 2. Carbon 2 has 1 more and another one right there. So if actually I can draw. So this is, there's these carbons, and these are the carbons attached to the phosphorus initially. So it would be these ones. And then when you react with a carbonyl, let's choose blue, read these carbons and these carbons. So yeah, this is the alkene you would form. Okay, thank you guys so much for watching. I'll see you guys next time.